Welcome to Hartman Math. This is lesson 5.2, graphs of inverse functions, part 1. We're going to see how graphs of a function and graph of its inverse, how they relate to each other. So example number 1, we've got our function f of x. First thing we want to do is find the inverse function. So that goes back to our previous lesson where step 1 of step 1 here, find the inverse, was to rewrite it out of function notation into standard y equals notation. So we replace f of x with y. Step 2, finding the inverse, we're going to switch the x and the y. And step 3, we're going to solve for y. So in this case, we would want to undo the minus 1 first. We're going to add 1 to both sides. Then we're going to want to undo the half. We probably don't want to divide by half. Probably a better idea would be to multiply by the reciprocal. That would get rid of it. If we multiply both sides by 2, half of 2 is just 1. 1 times y is y. We get y by itself. We're going to multiply the left side by 2. Be very careful. It's very common as a mistake to only multiply the x by 2. It has to be the entire right side. So it means 2 times that quantity of x plus 1. And we probably would want to distribute that as we rewrite it into inverse notation. F inverse of x is equal to 2x plus 2. So we multiplied both terms by the 2. There's our completion to step 1. We found the inverse. Step 0, okay, we're kind of going backwards here. We're going to graph the line y equals x. This takes us back to Unit 1, linear functions. It's kind of weird, such a simple looking equation is one of the hardest linear equations for most students to graph. Let's see if we can stick to the basics. It is y by itself, so it looks like it's probably in slope-intercept form. Y equals mx plus b. So we're going to plot the y-intercept first. Well, that would be after the x. That would be 0. So we're going to start with a point at the origin. Then we're going to use the slope to get to the second point. The slope is the number in front of the x, also invisible, but this time a multiplier, so it's an invisible 1. Slope is 1, which means we would go up 1, right 1. Now we probably want to do that a few more times. Up 1, right 1. So point, 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 and so on. Needs to be really accurate. Use a ruler, ID card, straight edge of some kind. And we're actually going to make this a dotted line because it's just there for reference purposes. So it's this line that passes through the origin. It's in quadrants 1 and 3 and actually splits those quadrants in half. There's our line. All right, step 2, let's graph our original function. This happens to be a linear function back to unit number 1. We can use that y equals mx plus b approach. Negative 1 is on the y-axis, so our y-intercept is 0, negative 1. Right there. The slope is 1/2. Up 1, right 2. We're going to want to do it a few more times. We do need it to be very accurate. So up 1, right 2 a few times. With this straight edge, we're going to draw the line. We're going to put arrows to signify that it goes forever in both directions. Step 3, we have found the inverse. Let's graph the inverse. It's a linear function. Start with the y-intercept. On the y-axis at positive 2. The slope is 2, which is the same as fraction 2 over 1. So up 2, right 1. Do that a couple times so we can get a nice spread apart points so we get a good exact line. Draw that in. Use a ruler. And now we're kind of comparing our lines. And we're really comparing them to this line, y equals x. What do we notice? What's our conclusion about our lines? As if they're here, it acts as a mirror. It's kind of the same on both sides, where it's a reflection. One of them is a reflection of the other over this line. That's our conclusion, is that the graphs of inverse functions are reflections of each other across or in that line, y equals x. And that's going to have to be a common theme as we explore other inverse functions. We have to make sure that that is true, that they are in fact reflections of each other, their graphs are. All right, your turn. Pause here in different points as we go through the steps like we did in the last example. First, find the inverse of m of x. Hit play when you're ready to check that. All right, let's go through our process. Y equals, switch the x and the y, solve for y. Now it gets a little challenging as far as what do we want to undo and in what order. We can't get rid of the plus 2. It's buried inside of the parentheses with something else happening. So maybe we should get rid of this first. We have to undo the cube. What's the inverse of cube? Cube root. We will cube root both sides. Now we can get rid of the plus 2. We can go subtract 2 both sides, make sure it happens outside of the cube root, not under the root. So it's all by itself, so make sure that the bar only goes that far. All right, so we can now rewrite it as m inverse of x equals. That's step 1. Here's our line. It's going to be the same line every time, that line of y equals x. So step 2, graph the original function. Probably know what step 3 is, to graph the inverse function. Might help if you use different colors. But go ahead and pause here as you do both of those. All right, so this one, we're going to look for our inflection point first. X coordinate would be -2. K afterwards, 0. -2, 0 is our inflection point. And then our base graph, we're just going to need those 3 key points. For cubed is with an A of 1, right 1, up 1. Left 1, down 1. Careful with the shape. Cube takes us back to unit 3, where it looked like this. It's going up the page. So we need to go up the page. Now, in order to get the right shape, because I know some of us have trouble getting that right shape, start here, pass through, bend in one direction, going up the page. It's got to bend like this. Don't ever go straight up, because we know that our domain would be negative infinity to positive infinity. It's got to keep moving to the right. Same thing over here. Now start at the inflection point, the center point. Bend it the other way. There's our m of x. Now, step 3, graph the inverse. All right, so again, h and k. Inside here, that's going to be the h. 0, comma, k, -2. That's our inflection point. Okay, A out in front, 1. So, right one, up one, left one, down one, but this time it's cube root, so it can't go up the page. It's going to have to go sideways, like an S. So if we go here, through here, bending this way. So instead of bending up, it's bending out. That's our first part. And then we'll reverse it going here, bend one direction from the center. And we can kind of see that they're reflections of each other, mirror images in this line y equals x. Example number 2, assume that -1, 5, -2, 0, 6, 3 are points on the function f of x. Plot those points and label as A, B, C. Very important. You have to use capital letters because that's how we indicate points. So let's plot the points and label them. -1, 5, -2, 0, 6, 3. Labeled A, B, C. Next, plot the points that would have to be on the inverse function. Label them as A prime. It's like an apostrophe. We say A prime, B prime, C prime. Now, how do we do that? There's a couple ways. We just saw, well, a function and its inverse are reflections of each other in this line. So we can take point A and reflect it across the line y equals x. But it's a little bit hard to visually see where that happens. Or we could go back to one of the things that we were just doing, are find the inverse process. It was a 4-step process. Remember step 2, it was switch the x and the y. We can do that point by point. So if -1, 5 is point A prime, which would be on the inverse, we just switch the x and the y, 5, -1. That's where A prime is. It is a reflection. But it's probably easier to locate it than just thinking of that reflection. So 5, -1. 0, -2. Switch the x and the y. 3, 6. Switch the x and the y. So those are our points on the function. We don't exactly know what the function looks like, but we don't need to generate those points. All right, it says draw the line segment that connects A and A prime using a ruler. Connect here to here with a line segment. Yep. And B to B prime. And C to C prime. What do you notice? What do you notice about these segments? Think about it for a moment. You should notice 2 things. First, this distance and this distance are the same. They are, we would say, geometry terms, congruent, the same length. So a lot of times we may do to indicate that is we'll put a mark here and here to say, yeah, those are the same length. These are the same length. So not the same as this, so I'd use it 2 marks, 2 tick marks. And then same thing here, this and this are the same. What else? Well, when this segment intersects this line, what do you notice? It intersects at a right angle, at a 90-degree angle right there. So we would say that this line y equals x is a perpendicular bisector to each of these segments. Bisect means cuts it in half. Perpendicularly, it created right angles. Example number 3, based on that idea, if we knew that negative 5, 12 was a point on the graph of p of x, then that would guarantee you would know that what point is on the graph of its inverse. Well, it would have to be 12, negative 5. The reflection across the line where we switch the x and the y. Your turn. If smiley face, heart is on the graph of d of x, then you would know that what point is on the graph of d inverse of x. It would have to be the point, heart, smiley face, switch the x and the y. Example number 4, this is a review problem. Find the inverse algebraically for p of x equals x squared minus 6, where x has to be greater than or equal to 0. In our next lesson, we're going to see why this needed to be here. For right now, we can kind of ignore it and just focus over here on our process. Algebraically find the inverse. Step 1. Make it y equals. Step 2, switch the x and the y. Notice that the exponent stayed where it was. All right, let's go from there. Now we got to solve for y. So let's undo the minus 6. Let's add 6 to both sides. Now we have to undo the square. So we're going to need to square root both sides. And that leads us to p inverse of x is equal to the square root of x plus 6. That's it for today. I'll see you next time.